Hello, I'm Amit Bhardwaj, Senior Director of Product Management here at Juniper Networks. We live in very unique times where the boundaries between service providers, cloud providers, and data centers are dissolving. Today, we see a majority of traffic going over the top of service provider networks. All the applications are now hosted in the cloud, and hence the service providers do not monetize these applications. There are new inflection points though, where applications need to be hosted closer to the end user. This evolution creates new opportunities for service providers, but this is only possible if SPs can architect their networks to scale and realize the importance of service placement and agility. And in this process, show how service providers can monetize their essential role in service delivery and quality of experience. We continue to see the traditional challenges that service providers face. Today, from an operational perspective, it is very hard to scale. Over 80% of service provider cost comes from operations and maintenance. Any changes from a service or architecture perspective requires significant investment from the operator. In addition to regular maintenance and build out, service providers also need to retool for 5G. Clearly, there is a lot of hype around 5G, but there is also a lot of potential, and with that, a lot of concern over how best to engineer 5G into service provider networks. Not only are service providers facing challenges economics from the bandwidth curve, there are also unknowns to deal with as we are experiencing with the current pandemic. There are ways to address these challenges. First, with bringing cloud scale, and then leveraging that for creating differentiated services. We are truly at an inflection point. With the right decisions, service providers can be ready for the next set of known and unknown challenges for 5G and beyond. The outcome will be new networks that enable a wealth of high-performing applications, including new groundbreaking opportunities yet to be envisioned. This transformation will require capability to deliver service anywhere with cloud-based architectures. On the left, we see how most service provider networks are designed today. Each part is a siloed network segment, like ships that pass in the night, performing their unique and isolated network operation. This approach has multiple issues. Each segment needs to scale independently, which means a bottleneck in one segment creates back pressure in all segments. Operations are isolated and uncoordinated. Scaling capacity to a service in this paradigm becomes extremely difficult, requiring complicated and often manual operations in every segment. Even if you can throw money to overcome these challenges, it is highly unlikely that you will realize the low latency performance requirements of next generation services and applications. On the right is the solution to these challenges, an underlying end-to-end IP service fabric, applying cloud principles to a transport architecture. Here, the IP service fabric, consisting of both physical and virtual network elements, spans the entire network architecture from access to core. Select network functions are virtualized and disaggregated, enabling them to be distributed to strategic locations throughout the network. Essentially, wherever it makes sense from an SLA or CapEx, OpEx perspective for each individual service instantiation, optimizing the quality of experience for every individual user. Virtualized network elements are capable of cloud scale, flexibility, and agility to the service delivery network. This also creates new benchmarks for highly customizable SLAs. And when it comes to 5G-enabled services and applications, this architecture is essential to deliver upon new low latency standards and expectations. If this sounds like hyperscale type benchmarks, you're right. This IP service fabric brings data center economics, automation, and scale to complex infrastructure deployments essential for cloud plus 5G plus AI era. A single IP service fabric is designed to support all services. Let's look at a few examples. Most of 4G is deployed as dedicated RAN deployments. Every time a new cell site needs to be set up, a new radio and a new baseband unit needs to be deployed. The cost is n times each deployment. As we go to 5G, a siloed model approach would make 5G very expensive, as 5G requires 20 times the sites as 4G. The IP service fabric architecture allows the separation of radio from processing, hence allowing only radio deployments at the cell sites. All radio processing can be centralized in the cloud using pools of virtual distributed units and central unit operations. It's like creating a client-server architecture for the RAN rather than putting a mainframe at every 5G site. Another service in the network that will benefit from IP service fabric is Remote PHY, or R5 for Cable Distributed Access Architectures, or DAA. In cable space, a physical cable modal termination system, or CMTS, was expensive and difficult to deploy and required manual intervention to scale. The limited reach of analog transport from the physical CMTS is cost prohibitive. Every iteration of technology required system-wide physical upgrades, reducing competitiveness. Now, with the DAA approach, Remote PHY is being disaggregated from CMTS and allowing a fiber-deep presence in the networks. Similar to the RAN, the CMTS function is being completely virtualized into the cloud. The IP service fabric between Remote PHY and virtual CMTS provides a common transport, not just for cable broadband, but also for other services. Now let's take this concept to the next level, leveraging the low latency benefits of this architecture. You can host any application anywhere. This can be a network function like RAN, Remote PHY, or any user application. Examples of such applications include CDN, gaming, self-driving cars, mission-critical applications, etc. These create new monetization opportunities for service providers. It enables service providers to differentiate their offerings from over-the-top players. In fact, it creates the opportunities for today's over-the-top and cloud-based providers to become a paying customer for the service provider. Earlier, the data was going to the cloud. In this paradigm, the cloud is coming to the data. In a nutshell, this is a huge win for service providers, reducing costs for operations and service upgrades while paving the way for new revenue streams. That is not all. There is more to it. To understand that, let's drill down further into RAN evolution. As mentioned in the previous slide, the majority of 4G RAN deployment types we see today are called distributed RAN or DRAN designs, with the radio and physical baseband units sitting together at the cell sites based on proprietary solutions, creating a vendor lock-in situation. The IP service fabric architecture creates the ideal foundation for deployment of a cloud RAN or CRAN, a distributed RAN architecture that places virtualized network functions in the cloud to improve cost models while virtualizing scale. Next obvious step is to remove the proprietary locks between the radio and the DUCU. The IP service fabric allows RAN operators to evolve to a new open standards-based RAN architecture. A community-led group of both operators and vendors, including Juniper networks, and presently in the process of defining this new standards called Open RAN or ORAN. This breaks the lock-in between radio and DUCU. It will introduce significant cost savings by fueling a new ecosystem for operations to select best-of-breed solutions. The ORAN initiative is also supported by many governments for creating a secure and financially viable 5G infrastructure. Juniper's SP transport strategy is to enable this IP service fabric for all service delivery options anywhere in the network. First and foremost is to adapt the network to cloud scale for all services and simplify the complexity of operations. For example, network will need to address various entry and exit points while maintaining SLA per end user application. Low latency tasks will be processed at the edge, while less urgent workloads can be sent through longer links into the public cloud. A what-if failure scenario will need to determine not just 5 nines of performance, but also how to maintain lower latency-driven SLAs. Customer experience becomes paramount, both for operator to drive new use cases and for the end customers. Juniper will drive customer experience through 3 pillars consisting of a fully automated cloud-scale fabric and optimized service delivery platforms. Automation is no longer a buzzword. Day one automation can be applied to simplify deployment provisioning and day-to-day operations. This first step leads to fully closed-loop network automation to self-correct and self-optimize operations. Bringing cloud scale to transport is key, but it also introduces new challenges. For example, every truck roll is significantly more expensive than in a data center fabric. This brings new unique requirements to drive SLAs for next generation services. Finally, platforms are a key from a form factor, speeds, and feeds perspective, but these should become transparent when combined with automation and cloud scale. So let's talk automation. Effective automation starts with a properly designed architecture. The foundation needs to be strong to eliminate the need for patchwork later and to make things hold together. The foundation starts with programmatic interfaces and telemetry on the network elements that form the fabric. This is where Junos plays a key role in driving consistent netconf-YANG models across the portfolio on ACX, MX, and PTX series platforms. Key pillars to the implementation of automation include Juniper HealthBot, providing workflows for network health and operations. Juniper Northstar, a market leader segment routing controller, providing robust traffic engineering capabilities refined over decades of real-world application and developments. Juniper also brings its partnership with Anuta Networks for EMS and service provisioning functions. Combined, these pillars provide a comprehensive set of capabilities for device management, service definition and provisioning, day one automation of device turnup, and advanced traffic engineering. With this foundation, service providers will have end-to-end orchestration capabilities such as network slicing for deterministic SLAs and performance monitoring for highly agile and reliable service delivery. The architecture is completely open for creating workflow automation with other service controllers. For example, network slicing coordination with the RAN service controller. From here, the next logical step is intent-based automation. While the concepts and ideas behind intent-based networking have been discussed for years, the advancements in machine learning, APIs, and telemetry are making intention-based networking a reality. Intent-based operations help to design, implement, and operate networks to improve network availability and agility. Intent-based networking captures and translates business intent into network policies that can be automated and applied consistently across the network. Streaming telemetry provides data constantly to monitor network operations. The tools discussed on the previous slide provide the ability to translate intent into actions performed. Software automatically enforces policies that the network manager has defined. Actions can be taken based on defined workflows to create closed-loop automation. The evolution leads to machine learning that will fully automate implementation of policies and corrective action. Juniper is already doing this with Mist on enterprise wired and wireless LAN, DNA that Juniper will bring to power the WAN tools. Second pillar of Juniper's strategy is Cloud Scale Fabric that provides service differentiation and scale. Even though it has some similarities with Data Center Fabric, it is also different in that it brings new challenges. Unlike within a data center fabric, the service provider's fabric is deployed across a wide geographical area. The service provider's access leaf could sit in the same CO, a remote CO, or even on a pole. A truck roll to address failures is just as expensive as before. Hence, the IP service fabric needs to build around courier-class solutions. Further, the network needs to address applications that need strict timing and sync, with even more stringent requirements coming from 5G needing Class C timing compliance. The good news is that Juniper continues to innovate with courier-class capabilities and industry-leading routing stack in Junos. We are further simplifying deployments by requiring less protocols, less states, and enabling more programmability. Junos provides widely deployed implementation of MPLS, segment routing, and next-gen VPN technology such as EVPN. The consistent capabilities of single Junos operating system across the network makes it easy to implement policies when designing new services and routing your services traffic.
A frequently discussed technology to implement policies is network slicing.
Network slicing is essential to monetize 5G networks. It allows operators to charge for superior low latency SLAs and for high bandwidth applications. Network slicing will enable different SLAs on a single network. If you're running so many different services on the same network, how do you separate your premium from economy SLAs? Juniper here brings market-leading automation stack with consistent and secure implementation of slicing technologies throughout its WAN routing portfolio. Juniper is fully open to work with various RAN and mobile code developments for end-to-end network slicing. Our goal is to provide unmatched quality of experience when it comes to this fundamental need for next-gen network experience.
And finally, we come to the physical layer. Speeds and feeds are always needed in the right form factor. Juniper led the transition to 100 gig. Now we are leading the transition to 400 gig from the access to the core with best of breed and comprehensive end-to-end portfolio. MX is the workhorse for service provider networks worldwide. It is the Swiss Army knife that drives all use cases. PTX, optimized for the core and peering, leads the industry in performance and economics. ACX addresses access and aggregation use cases. It is 5G ready and is market-leading deployed platform for remote PHY and DAA use case.
Juniper's IP service fabric enables a multi-service architecture that seamlessly connects your physical, virtual, and cloud resources. The next-gen service providers that are successful will be those that can transform the networks to thrive in the cloud plus 5G plus AI era. Juniper is driving three-pronged approach with innovations in automation, cloud scale, fabric, and 5G platforms. As networks and services grow in complexity, the IP service fabric simplifies operations by creating the foundation for closed-loop automation and machine learning while paving the way for next-generation low-latency applications. Juniper's comprehensive portfolio of orchestration and management tools checks all the boxes of operational requirement for your next-generation service architecture. Juniper's active participation and leadership in the open standards community ensures that your partnership with Juniper will leave the door open to an ecosystem of best-of-breed solutions as seen in remote PHY and creating the foundation for 5G. And our broad offering of routing and switching with solutions will help you create a service delivery architecture that your customers will value as their own business critical asset. With that, thank you for your time and attention. As we can all see, even during these pandemic times, network has become a critical asset. And as we move to the 5G era, network is going to be even more critical, not just to serve the applications, but also to monetize the 5G. I hope you enjoyed the rest of the sessions in this virtual summit. Thank you very much again.